say next I'm going to go over to the real examples. So that is the iris flower data set I mentioned in that class. So in that data set, the very classical machine learning data set was used in many examples. So that's the reason it serves many purposes. That it's very small data sets though, I should mention that. So this data set was tried to, convention was used for solving a classification problem. And this data set and describe this describe each flower using 4 features, and then extract the width and length of petal and the sepal from the flowers. And those features are extracted manually by somebody else, by the people, right, manually. So in the data sets here, we only have 4 numbers to represent each flower. So they don't be confused. They're not, those problems here, they're not looking at the flower image itself. And of course, that would be a different problem. A different problem say, well, give me images. And can you tell me what type of flower it is? So that would be a different problem. And for that purpose, of course, we have methodology to address that. And that will be somewhat the focus of the deep learning models and to address exactly this problem. For here, we're doing more classical way. And the classical way is people already extract these 4 features for you. And those 4 features describe this flower here. And this petal length, width, sepal length, width here. Well, let's look at this data set here. And you can actually load this data set from this modules called scikit-learn. Scikit-learn itself includes multiple data sets. And one of them is this iris flower data set. And you can load them so that you don't need to download the data set and load it yourself. You can do it right away. So that's what I'm going to do here. From here, you load them. So now you see the flower data set and provide your description as well. But I want to skip that. So that for now, you can see the names of flower, it's Septosa, Verticolor, Virginica. So then they talk about the features here. The features of each data sample, including sepal length in centimeters, sepal width, petal length, petal width. So there are 4 features. It provides some of the background. For now, for us, we're going to do this guys here. Okay, let's try something simple here. So let's see. All right, I'm gonna plot a new block of code here, and I'm gonna start from the very beginning here. I'm gonna look at the data visualization, exploration. So this section here, let's look at that. So this data set here called iris data sets here. It has is a dictionary right now. So I'm going to look at this data itself. This is data of the iris data sets here. You can see it is represented as an array. As I mentioned in the lecture here, you can think that it's represented as a matrix. So the reason for that is much more efficient, as I mentioned in the data mathematical notations part of the lecture, in the last lecture. And this is the matrix here. Well, let's assign this to a variable called x here. So this is my matrix, and this matrix represents the features I have. Look at the shape of this matrix here. This is a 2-dimensional array. It contains 150 rows and 4 columns. So 4 columns represent the 4 different features. If I want to look at the first data set here, that will be x0 here. So this is the 4 features I have. And this represents the x values. And sometimes so there are different terminology for this type of x here. So right now, x here, so essentially we call it the features, it has 4 features here. And sometimes we also say this input x here is a 4-dimensional vector. And because it has 4 values, it's 4-dimensional vectors. And sometimes people also use the terminology called attributes. Say, what are the attributes of x here? And that is the x here. So there are many terminology, but for now, we unify them, we just call them x here. So this is x0 representing the first sample, and x1 representing the second sample, and so on. So, but everything together is represented in this matrix here. X here is a 150 by 4 matrix. So which means this data set here has 150 samples. Each sample has 4 numbers attached to it, and then 4 features. So this is the x here. And what are the Y values? These are the target values. Let's look at them. Iris data sets here, and these are target. These are Y values here. Y value is the target, and you can see again the target here are now represented by numbers. So it's very important here. Even though the real target are the 3 types of flowers, right? And the name is a flower. But when we convert them into the code, and we represent them in terms of numbers. So it's very common to use the integer numbers to represent the target here. Start with 0, and then move to the 1 and then 2 here. So 0 represents one type of flower, and the 1 represents the second type, 2 represents the third type of flowers. So it's a very common way to in the case of a multi-class classification, we represent the class with the numbers here. So they are typically between 0 and k minus 1 to represent k classes. So this is the target labels of these data sets. So essentially, I want to build a model based on each individual X4 features. I want to predict labels of the data sets here. So that is the problem with this one here. Well, so that I mentioned last time here, before we do that, let's look at some of the simple visualization, some statistics of the data sets here. So for instance, let's look at the first features. So let's say I want to look at the first feature. So the first feature now I'm going to say plot all the column values in the first columns of that, and that will give you all the values of the first column of this data sets here.